Hello, everyone, and welcome to Lesson 7 of C# Bootcamp, or rather, Full Stack Bootcamp. This time, we will go through a topic of object-oriented programming, and I'll try to go through everything you need to know about OOP, at least the most important part that will work in 90% or more scenarios. And we will put everything in the context of Web API. Practically, we'll make it work and enable us to even simplify the most complex business rules that we will soon install. So let's get into it. All right. Give me a moment as I share the link to the lesson. All right. Let's start with what is object-oriented programming? Object-oriented programming is a paradigm which we use to model real-life concepts in code. So, for example, in last lesson, we had a shopping list and a shopping list item, both of which were real-life concepts, and we modeled those concepts through classes. So you can see a class with a name shopping list and how it models a concept. Objects, on the other hand, so classes are blueprints. They define how an object looks like, what we can do with an object. Objects are instances of classes. So, for example, this is an object, a list of shopping lists. Do we have any more objects here? We do not. All right. In any case, we create objects using a new keyword. And then we can access those objects using a dot. So, for example, here, I can say shopping lists dot, and you can see all that I can do with this object. I can do pretty much like many things, right? So this is an object. All the stuff that I can access from an object is called members of that object. Those are member functions. Or not necessarily functions, but it can be properties as well. Fields, properties. What is a property? If I go to an item class, item has a name, price, amount. All of those are properties. If I delete get and set part, this is no longer a property. This becomes a field. So a difference between property and a field is a get and set part. A field is data. A property is that field under the hood plus getter and setter methods. But we treat them in a really concise way, and there's almost no difference semantically comparing a field and a property. We never make public fields because they are data, and data has a tendency of mutating and becoming invalid too fast. It's important to understand that often if we expose data publicly, we are bound to be hard dependent on both exposing reading and writing it. But sometimes we want to have a choice of allowing others to just read our data or write our data. And that is a very big and important choice. So my property could be just a getter, it could be just a setter, and it could be both. So object class defines how an object looks like and what we can do with it. This object has a name, price, amount, and we can get and set all of its fields. So let's go back to a controller and let's add one more endpoint. And I will create a HTTP post method, and I'll call it create random item, or rather get random item. So it will be HTTP get. And I'll say item random. Get random item. So this endpoint will return a random item. Let's create an item. We can create an item or any other object using a new keyword. So new item means we're creating a new item. And now I can assign its properties. And I will randomize them. So I will create a randomizer here. And I'll say that your amount is times 100, 10, 100, yeah. So this means it's somewhere between 0 and 100. Next, price, again, is somewhere between 0 and 100. And I convert this. Well, I will just add letter M here, so it doesn't get converted that way. Okay. So I'll convert this to decimal. Right, I need brackets here, sorry. And name will be some gibberish. I can do encoding, Unicode, get string, and I can pass bytes, right? So I can do random next bytes. And this it should work. Oh, next bytes. How many bytes? No. Does it return anything? It doesn't return anything. Okay. Next bytes basically creates bytes array. And remember, bytes are essentially just random data. So I can populate that bytes array with random bytes. That's what this does. And then I can feed those bytes and get a string out of them. And this is the item that I will be returning. Don't pay much attention to the random factor of this. It's all just an illustration. So that's all. And I need to return a new item. So I'll just say, okay, here you go. Done. Let's see what we have. I will need to create a new endpoint, HTTP GET at shopping list. So I'll go to Postman and I will create a new request at this endpoint from the last lesson, and I'll rename this request get random item. And if I run this, I get 404 not found because I'm not running this API. So let me run this API. I'm running it. And if I hit, you can see some gibberish. If I run again, you can see some really, really weird characters being printed. And for some reason, Chinese or Japanese mostly. I don't have an explanation why. And then you can see price and amount as well. All right. So this is how you create an item, an object, in other words. And there is a shorter syntax for what I did. If I move bytes here, boom. Okay. So if I organize it this way, I can refactor a little bit using object initialization. So when I create an object and immediately assign values to its properties, I can do this. So this is a shorthand for writing what I wrote before. Makes things slightly more concise. Maybe not more concise, but readable, more readable. Okay. So we have a new item which we return, and let's just make sure everything works as before. As you can see, random stuff. Instead of Unicode, let's return ASCII, and now you should no longer see those random characters, and it should be American. They are not American, okay, because I don't know why. It goes out of range. Okay. So be it. Let's not play around with encodings. It's not my strong point. The question mark, if you're curious, is because the encoding does not support the byte. The byte is out of range, but I still cannot justify why is it like this. But okay, sure. So be it. Okay. Next. So this is how you create a new object. Just because we are creating objects and using classes at the moment does not mean that we are being programming in an object-oriented way. There is a lot more to it than just those two things. Again, Object-oriented programming is used to model real-world concepts into code. Ideally, when you talk with a business person and they talk in terms, those terms will be taken and expressed in code, ideally using the same definitions. Not definitions, but the same vocabulary. So if I have a shopping list, I won't call it an items list. Business told me it's a shopping list. We agreed on such a definition, such a term, and so that term will be applied in code as well. So that when a person reads it, they won't need to be that proficient in code to pick up the meaning that we wanted to express. Anyways, let's move on. The first pillar of object-oriented programming, encapsulation. We already applied encapsulation in our case, and that is this place. Encapsulation is basically grouping related data and behavior under one class. So we have an item, and an item is made of three things: a name, price, and amount. Those three things are called members of an item. And functions inside the class and fields or properties inside a class are called that class members. Cool. If we go to a shopping list, there is one requirement that we are still missing, that we are yet to implement. And that requirement is we need to get a total cost for all the items in the shopping list. Let's do that. So I need a decimal which will express the total. And I'm not really getting a total cost, I'm calculating a total cost. It's a much better way of saying it, because it's not just getting something that's calculated, it's calculating. And basically, I need to sum the prices of every item in the list. And therefore, I will start from total price, total cost is 0. And I basically go through every item. I go through every item. And I take their total cost. I take their cost and I sum it to the total cost. And then I return it. And that's the total cost of all items in the list. Simple. Imagine if I didn't have this method. What would happen? Let's assume that I don't have this method. And let's say I need an endpoint which evaluates how much does every shopping list in my shop cost. So get total price. So I will have HTTP get with endpoint total, and I basically do this for each shopping list, and then I do this decimal total. And so I have a total cost for all shopping lists, and then I have a total cost for a single shopping list. And in the end, for every shopping list, items, I calculate their total cost, and I add the total cost to total cost. And in the end, I return that total cost as an OK, for example. So let's run this. And let's create a new request. Let's copy the path. And let's just say total, because that's what it was called, the endpoint. And if I hit send, I get 0. Let's create one item. So let's create a shopping list. And add item to shopping list. Let's add one more item, and let's add one more shopping list. And let's add one more shopping list to that item. So if we get all shopping lists, you see we have 2 items in the first one item in the second one. And if I send a request to get total, we get this. Does it make sense? 119. If one item is 39 times 3, it's matching. So it works. But at what cost? This is really difficult to understand. We have a loop inside the loop. And these two things are doing almost the same stuff. It would make sense if we could simplify it. Let's try to do that. A rule of thumb when following object-oriented programming is stuff should, related stuff should be together, and you should always ask yourself this question: does calculating price of items in a shopping list, does it have anything to do with a controller? And the answer is, it has nothing to do with a controller. So I move everything from this part into the shopping list. And I create the method get total cost, calculate total cost. And I return the total cost. Look how much more simple the controller method becomes. Because I can simply do this now. And it even becomes more simple. And if I run this and open the Postman shopping list, and let's add 3 items to that shopping list, 1, 2, 3, and total price is still the same. Let's go back. We have a way to calculate total price of all shopping lists. Again, does this have anything to do with the controller itself? Is there anything specific to controller? And the answer is no, there isn't. So let's go through all of those controller methods and let's try to figure out how we could make this better encapsulated, because this isn't a part of a controller. I will create a new folder and I'll call it services. And I'll create a new folder and I'll call it models. And I'll move my shopping list and item to a folder called models. And I'll create a new service and I'll call it shopping list service. What is a model? A model is something that basically works with itself and doesn't interact with other classes. It's simple and doesn't involve any kind of infrastructural processing like HTTP or serialization or like very complex calculations that would involve some APIs. It just works with itself. For example, item. Item doesn't care about anything else. It's oblivious to everything else. And then we have a shopping list. And shopping list itself is also oblivious. But it is okay to still communicate with other classes that are models. If we are talking with other models, that's fine. But we are not allowed to talk with anything else. A model cannot talk with a service. A model cannot talk with a controller, for example. And what is a service? A service is basically a class that serves logic based on different models. And in this case, we have shopping list model, and this shopping list service provides logic for shopping lists. Let's get into action of moving logic to the right place. If you have any questions, please stop me and ask. So we go to controllers and we said this is unrelated. So we move this to the shopping service class, shopping list service class. Well, the shopping list serves the shopping list service serves shopping lists. So we also need to move this in there. We no longer need to make this static because the service itself, if we want to keep the state, it'll be enough to keep the service state static. Next, we will move this part of code to the shopping list service, and we'll call this public get total cost, calculate total cost. And we return that. It's a decimal. Next, we have it. Great. So for it to work, we need an instance of that shopping list service. Just like we had raw data statically, now we have a service statically. We will solve the problem of staticness in the next lesson when we talk about dependency injection, but for now, this is okay. So my total cost is now as simple as calling shopping list, calculate total cost. Look how complexity suddenly disappeared. From a controller which had a bunch of methods, having logic inside those methods is making the complexity worse, and it's not helping in any way. Thinking that using something, implementing something close to where it needs to be used is a good idea is actually a fallacy, because we suddenly need to care about the implementation on top of the way it's consumed, on top of the way that implementation is consumed. So as programmers, we should minimize the things that we should care about. In this case, we trust this works, and we just call what the service provides. And this is just a communication between two little classes. Imagine if we have a system with hundreds of thousands of such classes and everything was implemented in the same spot. It wouldn't be maintainable. And therefore, grouping logic and behavior like this is the essence of tackling complexity. Let's continue. So we need a way of adding a shopping list to add a shopping list, basically. So the service will have a method to add a shopping list. I could remove this because the name, the variable type is redundant to the name, so I don't need to be so explicit. And this basically goes, sorry, I'm in the wrong place. In the service. Sorry, in the service. So we add a shopping list. Let's go back. So we do this. Next, get random item. Is this, which part of this is related to a controller itself? Only this line. So again, we can take this code and extract it away in, again, a component of its own. And I'll call this not a folder, but a class. And I'll call this items generator. And I'll say public item. What does items generator do? Items generator generates items. So I'll call a method generate. And then I paste this code and it says, well, you're missing random. I'll take the random as well. So I cut it and paste it in the items generator. I import the missing using statement for system text, I guess. And I am almost done. I just need to return the item here. And similarly, I can include this class in here. And simply call it get random item. I first generate an item from items generator, and I simply return it. Simple. Let's continue. If I want to get all shopping lists, I need to once again call the service to get shopping lists. So I will need to go there and add a method to get all the shopping lists which it has. And this is how it looks like. If we go back, I have that method right here. And my shopping lists now come from the shopping service. And I return those cheerfully. Next. This would look, so what belongs to controller now? This part, since it's not found, belongs to controller, and this part belongs to controller. So essentially, these lines are bound to our controller. This, however, is not. Let's go to this method. Find shopping list is definitely something that we can move to the service as well. So let's cut this method and move it to the shopping list service. Let's make it private. Sorry, let's keep it private for now. If I go to a controller, and call this from our shopping list service, you will notice it doesn't allow you to do that. And this is the point where we should realize that things in classes, the members, they have an access modifier. An access modifier can be either public or private. There are a few others, but ignore them for now. Public access modifier, as the name implies, says that this thing, the member, for example, get, it can be accessed from the outside, from outside of the shopping list class. So for example, I can access this method of shopping list service inside a shopping list controller. And I wasn't able to access find shopping list member method from shopping list service inside the shopping list controller because this method was private. Private methods cannot be accessed outside of a class. So I need to make this public as well. And we have a question. Would you recommend starting with models and working your way up with services controllers when constructing your project, or vice versa? There are two approaches how to build applications. One is called top-down and the other one is called bottom-up. What you are asking, the first one, if I would start with models, the answer is if I know very well how my application looked like, I can probably start with models just fine. Because I have a solid grasp of how it looks like, there won't be many changes. I understand my model. But if I don't, that means I'm just trying to see what works, playing around with stuff. So in that case, it's better like if you're not sure what's needed, it's better to start from a controller. So then the controller will drive the requirements and you will adapt a model based on controller's needs. So starting from a model when you're not clear on how it turns out is bad because your model will inevitably change. But when you start from a controller and let that drive the requirements, you can adapt the model or only create it when it's needed. So that's the main difference as I see it. I would say if you are more professional, go start from a model because that will be less waste. But if you are unsure, or if the requirements are changing hourly, I would just go for a controller. So if we go back to our controller, you can see this is working now, and I just need to replace everything with the shopping list service, the shopping list service. This one, however, is an interesting scenario. Let's look at delete. What happens if you're trying to remove an item that does not exist? Well, everything should be still a part of the same service. This belongs in here, so I must move it there. But then there is this validation. So I need to be smart about this, and I really have two options. So let me show you those two options. Anyways, I need to create a method called remove shopping list, and I pass it ID. So I first need to find shopping list, by that ID, and then I can remove it, right? What if shopping list is null? I have two options. I could return an indicator if this operation was successful. So if shopping list is null, I return false. And in here, I return true because it was removed. But it's a bit tricky at this point, and you'll see why. If I go back to the controller, let's remove shopping list. Was removed. So if it wasn't removed, we say that it wasn't found, which isn't that great, to be honest. You know, when we create methods, we should strive to make up our mind. Should a method return something, or should a method execute some action? A method should avoid doing both things, and returning a flag, whether operation succeeded or not, is counterintuitive, actually. Remove shopping list. I wouldn't expect that it returns a Boolean. What does a Boolean mean is up for our interpretation. Usually it indicates a success. If it's true, it's successful. If it's false, it's not. But it doesn't have to be that way. And we're left guessing. What we could do, make this much more explicit. This, however, will cut the performance a little bit, but this makes code more explicit. So if we have this thing like this, we will throw an exception. Argument exception, for example. It should be a custom exception, we all know that, but for brevity's sake, we'll keep it like this. Item shopping list. by ID was not found. And now we don't need that stuff anymore, and it can be void. So you can avoid Boolean as a success indicator altogether if you throw exceptions, because error is much more explicit than a Boolean. And how we change this logic to still work the same way it did, we try removing the shopping list item, and the exception we catch, we simply present that to the user, the error message itself. So this takes the complexity once again from the controller and moves it towards the responsible object. Something that's out of place is ripped apart and delegated to where it belongs. And so if I run this code and let's create a shopping list and add items, 3 items to shopping list, and let's get all shopping lists. We can see 3 items in shopping list by D2. And if I want to remove a shopping list by D1 and my shopping list is ID of 2, it says shopping list by D1 was not found. Yet if I remove the shopping list by D2, it succeeds. It succeeds because now if I get all shopping lists, I get none. Cool. Works. Let's continue. The next step, do we have anything else? Once again, we have something like this. Update shopping list name. Surely that as well could be in the same way be delegated to a service. So let's do this. Actually, let's just copy paste this whole thing in here. The method will be void. And once again, we do the same thing. And we throw new argument exception. And we don't do anything else. I'm not sure why we passed the whole thing. We just need a string. Which indicates a new name. Okay. And we could return once again a shopping list which was updated, but it's not necessary. It's okay to just return this. So let's do the same thing here, except with a different method. Okay. And update shopping list, we have the final thing, updating the whole shopping list. And again, the same logic applies. We take this out, move it here. We call it update shopping list by ID. And we pass the whole shopping list. and we move stuff here. And here we don't need this. And here we throw, once again, the exception. And that is all. So we do try shopping service update shopping list for ID shopping list. And if we get argument exception, we will return not found with that exception message. Lastly, what we could be doing, add item. Once again, the same principle applies, really. We take this, move it here, call it void. We don't need this. We throw an exception. And we don't return anything. There is that. So if we go out here, once again, we don't need this and can just do away with this part. Add item, shopping list ID, item. Yeah, this is fair enough. The rest looks okay. Again, this could be moved in here, but it really depends on how we treat something, how critical is not finding a shopping list is. If it's okay to not finding it, if it's an expected result, then this is okay. But if it's unexpected, if this result, the outcome of it influences some other operation, for example, add item, I cannot add an item to a shopping list which doesn't exist. So it's an exceptional situation. But when I'm getting a shopping list which doesn't exist, it can happen. Like random shopping lists don't exist. So I can simply return not found. It's a subtle difference, and it'll take time to get used to. Anyways, one last bit. When we have, right, add item, get, add item. Okay, everything is great. One last thing. When we talk about add item function, and we look closely at it, we should also realize, does this line belong to a shopping list service? Yeah, it does. We're using this method after all. What about this one? Yeah, it does. It still works, tries to aggregate many shopping lists. What about this? This actually is simply adding an item to a shopping list. So it's okay, but it could be simplified slightly. I could have this kind of method. Super simple one-line method, which slightly simplifies things. Now I'm acting with the members of shopping list. there is a nice principle in object-oriented programming. It says talk only with your immediate friends. If I'm accessing a list and then an add method from a list, it's quite different than accessing it directly from a shopping list, because I can mess up. If the only thing I can do with a shopping list is to add an item, I should say so explicitly. And therefore, ideally, I should make this private and remove the properties that this has and expose them through a public. This is a custom property that I'm writing right now, but it's okay if you don't understand it for now. So like this, by making a list of items private, I say that I can only get items, but not add them. But not clear them or reset them. I can only add stuff to the list, but not remove from it. That's the point. So you see, I can no longer break my stuff because I cannot do anything with those items. I can only get them. Okay. Okay. Let's run the API. Right, there is one more thing that I missed, and that's this thing. So again, update shopping list. What belongs to shopping list service and what belongs to shopping list itself? These guys are talking to shopping lists. So it would make sense that I would have a method called update shopping list, or simply update in a shopping list itself. Now I will introduce one more keyword, and this keyword is called this. And it's used to say that I am inside this object. I'm within this object. It's not necessary, though it makes it clear what I'm referring to. But we can do away without it. So I need to convert this to list. And that looks good. So my update method looks like this. And my part where I'm updating stuff will now be much more simple, because I can simply say old shopping list, update with the new shopping list. Super simplified. Let me double check the questions, just in case. No questions. Great. So that is how you split stuff. And let me try and see if it works. So I create a shopping list. I add an item 1 and 2 to shopping list. I create one more shopping list. I add one more item to shopping list with different ID. I will get all shopping lists. and I will update the shopping list. I will update shopping list item. Sorry, the name of it as well. Say 1. Cool. I will get random item. It still works. And I get total price. Does it make sense? Seems so. It seems so, because I have 2 shopping lists, 1 empty. Cool. And if I delete shopping list, which is an empty, so with ID 1, and get them once again, we now have a single clean shopping list. Stuff works. The key point here is that the complexity right now is reduced. Every method in a controller is just a few lines of code. So that's the essence of encapsulation. You take stuff that doesn't belong and move it to places where it belongs. And if something isn't needed, like in the case of a shopping lists, you simply hide it. All we need is to get all shopping lists, but we don't want to interact with them other than just adding new shopping lists, removing them or updating them or adding items to them, but we don't want to clear them, reset them, and do other things with them. So we hide stuff that we don't want to touch. That's encapsulation, grouping related stuff and hiding it. Next is inheritance. We already have witnessed inheritance because our shopping list controller inherits controller base. How do you think we have access to OK, created, deleted? There's no deleted. OK and created methods. How do you think we have access to those? And the answer is they come from this controller base. So what is inheritance? Simply put, inheritance forms and is a relationship between a child and a parent. A child is a parent as well. So all that a parent has, a child has as well. What does that mean? That means if every controller has those methods like OK, created, that means that every class that inherits a controller will also have those methods. And that what it has is the inheritance itself is denoted with a column symbol. Let's simplify stuff and make it slightly more practical for our scenario. It's likely that some shopping lists will actually be with taxes. We don't need this total price anymore. Well, yeah, we don't need this anymore. We do, but it's a property, so let's redo this slightly. Calculate total cost. Okay. Okay, for example, sometimes we might be interested in having subclasses and changing behavior, existing behavior. And in our case, what if we want a shopping list which doesn't just calculate a total cost of all items, but also applies taxes? So I will create taxed shopping list. And here's again that funny thing. Taxed shopping list is still a shopping list. It has everything that a shopping list should have. So I will, and the essence of this taxed shopping list is that it changes the way taxes are done. When we create a tax shopping list, we must provide the taxes that will be applied to this shopping list, and we will do so through a constructor. Taxes. Read only is a modifier, meaning that we cannot change the field. Decimal. So when we calculate total, and I'll just copy paste this, we will apply those taxes. And that's really it. But this won't work. And if we hover over it, it says method is never used. But the bigger warning, it says the keyword new is required because it hides method decimal. I'm having a method with the same name in a child class, and it's not valid. I can have the same name with that in the child class, but I must override it. And in order to override a method with an implementation, I must mark that method virtual. Virtual keyword allows me to specify default behavior of a method. So this is the default behavior of a method. And on top of that, it allows me to go to a child and override this behavior because I'm multiplying from taxes. But this doesn't really make sense because I'm actually just calling the same behavior on top of this one. So so the pure cost is this, and I'm taking pure cost and multiplying it from taxes, and I get taxed total cost is how this thing works. How do you put this to action? Let's go to, let's go to a shopping list service. When, let's say when we add a shopping list, let's say that we can apply taxes to it. If taxes are more than 0, well, if taxes are more than 0, so by default it's 0. Okay, I will do it differently. Let's have two methods. So one is simply adding a shopping list. Another one is taking that shopping list and converting it to a tag shopping list first. And again, I could. Yeah, I will. So tax shopping list. I need taxes, so I just say taxes. And then I must do the address, which is the address of the shopping list. Then I need ID, which is the ID of the shopping list. Then I need the shop name, which is the ID, the shop name of the shop name, the shopping list. And then I need items. I cannot do anything with items, so I will need to do a for each to move items from the old shopping list to the new one. So sorry, I will not do this. I will undo this. Ignore what I did there. We can simplify things. That was a bit overcomplicated. When we create a shopping list, we can either create this shopping list. So it will be /basic. Or we can create a shopping list which is taxed. And this is no longer a shopping list, but this is a taxed shopping list. And nothing else changes. Nothing else changes except this bit. So let's create a new request. Let's first run this, of course. Total price. We don't need this anymore. Let's run. We don't need this anymore because total price is computed, as you can see here. Okay, great. Let's go here. As we said, let's add a request. Create taxed shopping list. Cool. Let's move it here. Let's say this is basic, and let's say this is taxed, because that's how we changed our endpoints just now. So if we send this is the basic. If we send this, and provide it with tax, this is no longer basic. So tax is 1.1, 10% tax, for example. So if I create it with here, 2, for example, value text is not valid. Text. Okay, weird. Okay, I think I understand. It requires me to text. Do this basically. Nope. Text. ID. The value text is not valid. I don't have a value called text. Probably it's right. Text. That's the endpoint, and I'm using wrong method. It's post, not get. I don't know why are those gets. Okay, sorry. Taxes. So if I send, it says unsupported, obviously, because I must make it with a getter and setter. Object-oriented is a bit tricky with these guys. Because you need to work around issues like this, which is a bit annoying. I don't want to go into depth on how to properly work around this. Let's say that's how you do it. Let's just make this getter and setter. Rule of thumb, when in serialization, working with serialization, make everything getter and setter, because that's just how it works. There are ways around this, but it would be way too complex for this tutorial. So let's not go into too much detail, shall we? So calculate total cost. That's fine. Everything's fine. Except I need, create one shopping list and create another shopping list with taxes applied. Tax, I think it's called just tax. Double checking. Taxes. Okay, run. Great, and it says taxes 0. Why taxes 0? Because I honestly don't know why tax is 0. Taxes. Oh, E. I missed an E. You can see taxes 1.1 now. Let's delete shopping list by ID 2 twice. And let's create a shopping list by ID 2. Great. And let's get all shopping lists. Great. So let's add an item to each shopping list, to 1 and 2, and see the magic. If I'm getting all shopping lists, look how their totals would differ. First shopping list has 39.99, but the second one has taxes applied. So even though both things were shopping lists, one shopping list behaved differently, and I had no changes in the endpoints themselves. I was able to modify models, and that affected the behavior of where those models was called. That's pretty cool. And that's the power of inheritance. It allows me to take everything from my parent and add something from myself, or maybe override something from myself. In this case, I did both. I added a taxes property, and on top of that, I applied the taxes when calculating total price. On second thought, I didn't expose taxes here because shopping list, not every shopping list has those taxes property. So it wasn't simply shown here. Cool, isn't it? And that's inheritance. Once again, inheritance is a relation. It is not a tool for code reuse. It is a tool for modeling relations between classes. So use it properly. Don't use inheritance as a tool for code reuse. Use inheritance as a tool for modeling class relations. Let's make it even more complex. And let's say our tagged shopping list is actually made of policies. So I create an empty constructor, and inside it, inside my tax shopping list, I will have a bunch of policies for taxes. So for now, a class which is yet to exist. So I have tax policies right here. And I will create a new class called a tax policy. And a tax policy is something very simple. It's taxes private taxes with a method called apply, or rather, it doesn't have even that. It's just the method apply. So we apply tax policy to some number and we calculate it like that. So we can apply a policy to a price. So we return. So I don't know how this will be implemented. And yeah, for now, let's return 1. Not 1, but price itself. It doesn't do anything, this one. And I will apply inheritance once again to create two tax policies. One tax policy is fixed. So it takes a price, not the price, but taxes, and applies it to price, just like we had before. So these are my taxes. And my apply method I'll do a virtual here so that I can override. Is price times taxes. And I have another one called progressive tax, which has a list of policies. So similar to this, but slightly different. It has basically ranges of which tax should be applied when. And I will need another class called arrange now, which looks really simple. It's two things. It's begin and end. Or just begin. Or just end. Sorry, just end will be easier. And decimal taxes. Okay. And yeah, that's it. So fixed policy, takes those ranges. Or we just create them internally. So we create a new list of ranges. First range, if you earn nothing, well, if the price is under 10, there is no taxes. If the price is under 20, there is a little bit of taxes. If a price is over 100, there is double the tax. If a price is, need to write m to say it's decimal. If the price is 1,000, then that's the range. And finally, if the price is more than 100,000, you pay 20% on top. That's basically the policy. So what this will do, it will do a for loop. So it won't be a list, it will be more like an array. And we will do a for loop. So a typical for loop. A typical for loop. And we'll stop our for loop if the range is less. So if price is less than range and we put them in order, you see right here. So if I'm under 10, that means I'm in a range between 0 and 10. If I'm under 20, that means I'm in a range between 10 and 20, and so on. That means I apply that range's tax. Else, if I'm out of range, I will use a default super tax. 1, it's just 2, for example. Okay. Complex policy. This is non-trivial stuff no longer, but it's practical. It will happen in enterprise level software, something like this, 100%. And this is already very useful. Okay. So why did I do this? What's the benefit? And the answer is, I can now say how I tax my stuff. Maybe multiple taxes apply. And now I can apply both fixed policy, 1% taxes, on top of progressive taxes. Shipping this. Okay. Cool. Awesome. And you'll see the beauty of this. If I run my code now, I did 0 changes, yet I completely changed the way it operates now. So let's add 1 item to the shopping list. 2, let's change the price to this. Let's change the price to this. Let's change the price to this. And let's add 1 more item to there. And let's get all shopping lists. And the cool thing is that all those policies for total price now got applied. I could go further and apply policies per item when calculating their cost instead of a total, and that would be yet another shopping list implementation. I could even combine applying per item and then on top of that another kind of tax. The possibilities are unlimited, but that's besides the point. The point is that I was able to simulate this in a matter of minutes without changing anything. I wrote extra code. I didn't change any code. I'm still in the area of models, yet I am essentially affecting service and controller at the same time because they depend on a model. Model should be where all the business logic relies, as much of it as possible at least. What I just demonstrate is that by running a for loop in my tag shopping list, oh shit, I didn't apply those tax policies yet, sorry. So I no longer need taxes here. I can apply them here. So I calculate pure cost. And actual cost will be pure cost. And I will update the actual cost every policy that I have. So I will apply the policy against the updated actual cost. And in the end, I will return the actual cost. So with this function, I am applying all tax policies based on the cost, the total cost of my shopping list. So I can apply as many policies I want. And the key point here is I don't need to care what policy am I using. I didn't write an if statement here saying if tax policy is a progressive policy, then do this, else if, I did not need to write any if statements, yet I was able to apply different policies based on different conditions. Zero if statements and fluent code. And that, my friends, is the power of polymorphism. Polymorphism allows us to treat the same object in at least two different forms. So I was able to treat my tax policy either as tax policy or as a progressive policy or as a fixed policy. But I don't care. It works both ways. And therefore, I was able to store all policies, progressive and fixed, as if they were all simply tax policies. Let's create a shopping list once again and just see if it works. So 0 and 0, that's fine. And let's add items to my shopping list. One item, another item, yet another item, and let's get all shopping lists. So you can clearly see how this item's price was doubled. Then this got 20% more, clearly. And then this got like roughly 10% more. And it totals, well, actually, ignore what I said. These got summed. And the price, since it's over 100K, it got doubled. And then it got multiplied again by a fixed policy, which is 10%. So it worked. And that's polymorphism. Why polymorphism? Again, we don't need to care what type the object was when we initialized it. We just need to know how we can interact with it. Lastly, the last principle is abstraction. And it basically means that we create abstractions. We shouldn't care about the implementation of things. All we should care about is how we can interact with them. So we hide implementation and just expose interactions. In our case, especially in the case of progressive policy, we hit the fact that there is a range or an array of ranges of progressive taxes, and we just have a simple method apply. In the scenario of a shopping list service, we hit the fact that there is a list of shopping lists. We just know that we can add stuff to a shopping list, get and remove stuff from it, update shopping lists, but we don't do anything else with it. And we wrote stuff to simplify all that we could do with a list instead of specifying what we can do with this service. If I made this public, I would expose so many more ways I could interact with the shopping list and the service, and it would enable so many ways of breaking my service. Instead, when I expose my methods, I'm in a total control. Lastly, what is an abstraction? I already mentioned encapsulation helps with good abstractions because it helps us hide the data that we have. It helps us group the data under one thing, so we create good abstractions. Inheritance helps with abstraction because we can generalize our children through parent classes. We can inherit behavior and form relations between the classes by saying that one class is another class. And finally, polymorphism is like the pinnacle of abstraction because we can simply call a generalized form without caring what's under the hood. And that's the whole point of abstraction. It allows us not to care about how the implementation looks like. Tax policy is a pretty bad abstraction because it carries implementation which we don't use. There is a thing called an abstract class which allows having methods without implementation. And nothing changes in the rest of code. It still works. Abstract method, abstract class, is a so-called incomplete class. So child classes must inherit that abstract class and complete it. In our case, complete its apply method. And we complete it by saying override this method. Override this method. However, abstract class can carry implementation. For example, I could say that there is tax here, and it will work. I can say that, I don't know, I can say apply discount. Apply discount. Which will do something. I can say implementation inside abstract class along with abstraction, abstract methods. But in our case, all we needed was this method apply. Abstract class in cases like this is an overkill actually. And therefore, we can make this even better. How, you may ask? And the answer is an interface. An interface is the best abstraction because it has no implementation. All it does is specify which methods must be implemented. And so I update my code and remove the override keywords and allow my text policies to simply implement that apply method and carry no default behavior. I no longer risk forgetting implementing stuff and taking default behavior when I don't want to, because there is no default behavior. It is a contract that has to be implemented. There's nothing more than that. So interface is the best abstraction, hands down, use it. Now let's move everything to the individual files, and that would be all. So if I run my code once again, I now update stuff to be of I text policies, the interface, and it works. So if I add, if I get all shopping lists, nothing breaks. If I add item to shopping list 2 3 times and get shopping list by ID, you can see some taxes being applied, not double, but if I add one more item, you should see a price jumping significantly, because suddenly, well, ignore what I said. If I increase the price further, if I increase the price further, you can clearly see that this biggest price was literally doubled, because that's my tax policy. Cool, it worked. Both progressive and fixed tax policies were applied in a fluent way, and the code is quite fluent. So these are your first steps to object-oriented programming. And that's why I said that just because you are using classes and objects doesn't mean that you are being object-oriented. Objects are supposed to simulate real-world concepts. And in our case, we simulated how a shopping list would work, how prices would be applied and totals calculated. Understanding this is quite important. And it will take time getting used to it, because even though the idea itself sounds nice, it takes time to develop a good nose for what fits where. But if you practice, if you simply write code and consciously think where you put stuff, how you organize it, how you form the relationships between classes, and look at every line and reconsider, is this the right place? Is this the best abstraction I can think of? Does this make sense to the reader? Will my code work after a year or two? Will I remember what I meant? If you keep those things in consideration, you will be a great object-oriented programmer. So keep on practicing and you will rock it. That will be all for this lesson. Do you have any questions? There was a lot of stuff today, I admit. I a bit derailed myself, but I think it was very practical. Like this stuff is very practical. In terms of complexity, it won't be much more complex than what I showed you essentially. And I demonstrate you how you can control complex things with objects, object-oriented programming, how to reduce complexity. Every class by itself is super simple. It's just like several lines of code, a few dozens lines of code. Like if you look at it at a method, it's just several lines of code. Yet all together, they do create a complex thing. That's pretty cool. Let me comment this. Not comment, but commit this. Lesson 7 shopping list example. And let me add a link to the video. Well, I'll add that to the lesson. Okay. Anyways, if you have no more questions, I bid you farewell and good luck. See you next time when we talk about the inners of Web API. See you. Bye-bye.